So in my notes, we divide this session into 2 sessions. First session will be 4 speaker, and the second session is another 4 speaker. So the first 4 speaker is Fatur Rahman, Ade Wahyu, Ari Wijaya, and Lady Fitriani. So all of you can give your presentation in 7 minutes. And then after each session, we held a Q&A session. Yeah. So after 4 presenter, then we held a question and answer session. So you can present your work first, and then after 4 presenter, then we have a discussion. Is it okay?
It's great.
Okay, Miss.
Okay, thank you. So so we just start. We can start with the first presenter, Fatur Rahman. Please, you can start.
Is it okay if I share from my screen, Mbak? Because I have a lot of slides, but it's 7 minutes, so I would like to manage my pace by myself.
Okay, okay.
Is it possible by the admin? Okay, thank you. Okay, I hope it's everybody can see now.
Yes.
Okay, thank you very much, Bapak and Ibu, Bu Damar. Thank you for the opportunity. I would like to share my work in the next 7 minutes. I hope I not run out. So I would like to change a bit my title of this study, because I would like to focus on the change management effort. What I'm trying to do is the case study when I conduct the implementation of the integrated monitoring in managing investment project by BUMN in Indonesia, especially in the energy industry. So background of my study here, I think everybody know that BUMN in Indonesia is currently managing the end-to-end process of the energy fulfillment of energy needs. And then, as we know, BUMN usually have many projects, have a lot of things to handle from the project management A to Z. And then I think sometimes it's their pain point in conducting the monitoring. Many challenges are usually found in the project site. For example, the transparency, like it's sometimes hard for several projects that I found during my time of employment as a consultant. For example, in reconciliating the working progress to the stakeholder. Sometimes also in several projects organization that I work with, they also have lack in a continuous improvement culture. This is actually important when we have a changing business environment. So it is important to have it in the organization as well. And then sometimes the organization that is project-based organization also sometimes forgot in conducting the capability improvement. So it's one of the in the organization or BUMN that I see. And then the study that that I do now, that I presented now, is actually about the implementation of the monitoring for the projects. When we conduct the implementation of the digital monitoring, we usually work in the 3 aspects: from the tools, process, and people. For the tools itself, we usually in place or implement or install any digital solution. But my focus of this study lies on the change management, how we deal with the process change as well as the people change. I will try to explain it in the next slide. This is the overview of the supporting application. When I said a digital monitoring for a project, the overview can be described in this illustration. Usually it's depend on the every audience, like for example, for the C-level or the director level of an organization, they usually would like to have the high level monitoring. But then when we go down to the bottom level of the organization, they usually would like to have more detail, like at the activity level. This is example for the use case of the application integration. For the 5 or 6 years until now, I've been dealing with many organizations trying to implement the integrated monitoring that's integrate from the schedule control, cost control, as well as the dashboard. Like for example, here usually in the project engineer usually update the schedule, update the progress, and then it is reflected so that it can be paid, it can be invoiced, and all of the schedule or the construction activity as well as the invoice and payment activity should be reflected on the dashboard. So it makes easier for the higher level management to see whether the project is goes wrong or in the right direction. When we talk about integrated monitoring in the project investment, I think we have many benefits that we can have here from the visualization. We can also do analytics, like after we have the current project, the data can be stored to have some kind of best practice for the future projects. And also for a supervisor at the bottom level of the organization, I think they like to have the granularity. I mean granularity here, as I mentioned as I mentioned previously, they would like to monitor at the activity level. As I mentioned in the beginning, introducing the technology to adopt the digital solution of integrated monitoring for the investment project cannot be standalone. Change management is also key in how we can deliver the implementation smoothly. Actually, many change management initiatives can be done into the organization from the process perspective and then people perspective. From the process perspective, I think we can start from the simple things like improving the SOP, and also one of the discussion that should be going on during the implementation of the digital solution is what are we going to see in the dashboard for the high-level management. Many metrics for the project improvement should answer the fundamental performance on the project performance raised by the management. We can have the overall cost performance or progress or anything support like permits and license. And then implementing the culture is also important in the people change management. We can have we can encourage the culture of transparency from the project review cadence. We can make a project review in the organization for a certain frequency. It can be daily, it can be weekly, it can be monthly, and then we could arrange what are the stakeholders that involved in the project review cadence. This is important to ensure the culture of transparency. Anything on the other things on the people change management is on the capability building. As I mentioned before, on the project management, I think one of the important role is the cost controller and also the planner. I think they need to we need to build their capability in a certain organization to make sure the project delivery is going well. And this is the last question, Bu Damar. I think when we do change management, I think it's benefits the organization when we implement a new solution. It can benefit us in terms of the communication and also the culture. Culture is probably the most important thing when we would like to have a culture of transparency and also culture of data consciousness in every BUMN. I think it's good to make sure that as WNE that we pay tax to fund some of the project that currently handled by BUMN. I think it's good to see that they can execute the project in the right way. I think that's all. 7 minutes, Damar, and I would like to have you to discuss anything in the Q&A session.
Yeah, thank you very much for your presentation. We continue with the second presenter, please, Ade Wahyu.
I will stop share.
Yeah, please, thank you.
Can you see my presentation?
Yes, yes.
Okay, my voice is clear. Okay, thank you so much, Mrs. Moderator Damar. So I represent my colleague or my partners here to present our works entitled Eggshell Waste as a Potential Catalyst Support for ferro iron oxide in methylene blue degradation process. I am from Department of Materials and Metallurgical Engineering, Institut Teknologi Kalimantan. And let's talk about why. So we all know that textile industry use synthetic dyes, for example, methylene blue. And this methylene blue can cause an environment and health problem like we can see in the picture. So how we can deal with this problem? So there's a method called advanced oxidation process. They use phenton. Phenton is a organic compounds which can degrade organic compounds, by the formation of free radicals obtained from the reaction of hydrogen peroxide with Fa ions from iron oxide. There are two kinds of phenton, homogeneous and heterogeneous, but homogeneous has disadvantages such as active only in lower pH and high cost, but heterogeneous have advantages in active in wider pH, and it can be used several times. But heterogeneous also have disadvantages such as low catalytic activation. So how can we overcome this low catalytic activation? By using catalyst support. One of them is calcium carbonate, and we can find it in eggshell. So we use eggshell waste from the merchants because it has high surface area, large number of pores, and high yield value. And we combine it with Fe ions. How? We used a method called wet impregnation. So we mixed calcium carbonate and the Fe ions as a catalyst solution. And then we have a catalyst activation, and we evaporate it with calcination process. And then we have a pores catalyst. Thus, in this work, we will evaluate the degradation process with variation of Fe 1, 2, and 3% weight per volume. So briefly, the eggshell powder in 2 grams and veronitrate in variation of concentration 1, 2, and 3 was mixed and stayed at 350 rotation per minute and 300 degrees Celsius for 8 hours. And then we filtrate it, followed by drying for an hour in 1200 degrees Celsius. And after that, we'll calcine at 500 degrees Celsius for 3 hours. And then the sample were characterized by FTIR, XRT, and UV vis. And then from the FTIR result, we can see that the CO functional groups were disappeared in calcium carbonate orange ferroxide in 3% samples, as we can see in the yellow box. And then the FAO functional groups, as we can see that there are peaks in sample addition with ferro. It implied that the ferronitrate was successfully loaded in calcium carbonate. And then from XRD result, as we can see, there are two compounds that we can see here, calcium carbonate and alpha ferro oxide. As we can see that in sample A, eggshell powder only contain calcium carbonate, and then from B, C, and D is 1, 2, and 3% of ferro. As we can see in the B, peak of ferro were detected, and more profound or more often we can see in the C and D. But for D sample, we can see that the sample was amorphous like this. It is possibly due to the termination of CO, a functional group from the calcium carbonate compound that we can see in the FTIR before. And then the last, this is the UV vis result to evaluate the degradation process. As we can see that the 3% of catalyst Fa perform better degradation process of methylene blue compared to others, which is 24% and 38% in 60 and 120 hours. To conclude, catalyst calcium carbonate ferroxide was successfully synthesized by the wet impregnation method. Despite the addition of ferro, 3% could break calcium carbonate structure. They provided higher percentage of degradation process in methylene blue, comprising 24% in 24 hours and 38% in 120 hours among the other samples. So thank you very much. That's all from me.
Okay, thank you. So we continue to the next presenter, yeah, because the question and answer session will be at the end. So please, maybe Ari Wijaya is not here, right? So please, we continue with the last presenter, Lely Fitriani.
Yeah. Thank you very much. I hope my voice can be heard clearly, Mrs. Moderator. And before continuing, I would like to say happy Selamat Hari Ibu today for all of the mothers. Oh, and those who has mothers. And yeah, our research in here is about using the solvent extractions as a decontamination method for oily soil in Indonesia. So it is a research between myself and Pak Edwan Cardena. So yeah. Yeah, these are contents. And I would like to a little bit emphasize the background, which is the main purpose of this optimization research and analyzing what's happened in the residual soil. It's because of Indonesia has millions of tons of sludge, contaminated soil, and anything related to the spillage of soil into the earth, the soil. So it is very important to find a method that can reduce the volume of contaminated soil. Currently, the technology that has been implemented is mostly about bioremediation that has some controversy before, and also I can say most of them are landfilled. And my practical duty for day-to-day is working for the landfill, hazardous waste landfill in Indonesia. So when I saw there's still millions of tons of contaminated soil in Indonesia, we need to find how to reduce the oil content, how to recover its oily content if it's possible, and how to find that it is not harm anymore if it's possible to be discharged to the environment, or even though it's going to be landfilled, it's going to be, if possible, in non-hazardous landfill. So the environmental damage and cost would be reduced. So this is the significance of this, why I chose to be involved deep and deeper. Okay, next, this is the method. We are doing a sequence of research starting from optimizing, and then we are doing some implementation of chemical solvents, and then we put biosurfactants, and we doing the analysis about the TPH. TPH is the total petroleum hydrocarbon, which is the oil is recognized as a substance in here. So after we have the report about the performance of removal, we also analyze the residual soil. So whether it's going to be still very high polluted or there's some decrease. And then we also try a little bit kind of an ecotoxicology, like we are doing the germination index, even though this is very little. I hope this could be an inspiration for all of the researchers in here, probably for doing something deeper that has the baseline of this research. So yes, that was the sequences of the process. So these are references. We are referencing the method to analyzing some parameters using the US EPA and some research that has been provided before, while analyzed by statistic also to find which one is, in optimizing, you should find what is your constraint, what is your goal, and you got to find your what is the most contributing factors that can make your process much more optimal. So we are using statistical data, we are using previous reference, and also some recommendations that has been established prior. So for TPH removal, TPH is stands for total petroleum hydrocarbon. It's very easy. It's just before and after and divided to the original waste or a contaminated soil itself. So it's the performance. This is the very simple one, but how to analyze it, of course, we have those reference before. Okay, now we'll just jump up into the result. First, for the optimizing result, to get to know which one, mixing method, which one is going to be used. So we were using either its centrifugation or horizontal shaking. So when we were using the horizontal shaking, the centrifugation itself, because in reality, in drilling activities, for example, we have big centrifugation tools, which can be adjusted from 1000 RPM, and it can be more. And we also have horizontal shaker. So from that baseline, we have those two equipments on field. I put it back into the lab size. Either we're using just centrifugation mechanism, or we are going to do the combination between the horizontal shaking and centrifugation. We found that the combination, of course, giving more higher TPH removal. So in here we can see we have four different types of soil, contaminated soil, oily, polluted soil, and it has always the from sample 1, sample 2, at the sample 4, the removal of TPH always higher when it's combined. Right, and the second one, we are trying to do some we actually have some sequence in here, but I'll just jump up into the most efficient one because we were doing some random optimization, and then we are doing the random not really random, it's a range optimization, and then we found this Taguchi experimental method is more efficient to not so much samples, but you can the highest optimum result. So we found using the Taguchi experimental method, using the chemical solvents. Of course, we can have very high TPH removal, but using the biosurfactants is produced by the microorganisms that also produced in our biotechnology and bioscience lab in Institute Technology Bandung. And we found that for the single phase of extraction, the most efficient of biosurfactant usage could achieve 68.8%, while the highest removal from the chemical solvent, of course, could reach more than 96%. But we would like to find out whether, if we are doing for the second stage, is the biosurfactants giving can approach the same TPH removal for this decontamination of oily soil. It found that from these experiments, it could at least achieve almost 90%. So either we are going to use single extraction by using the solvents, chemical solvents as an extractor, or we're using the biosurfactant, but it's double stage. The result is still good, and we found that the biosurfactant has a result to reduce until 0.78% TPH, which is in Indonesia. The current regulation regulate 0.5% of TPH. But of course, for the chemical solvents, they can reduce it until 0.49. It is meaning it's already past the regulation. But then we are a little bit afraid with the metal content itself and the pollution for the remaining of the soil. But for biosurfactants, especially, we did some for this conference. I just put mostly about the biosurfactants. We can see using this FEIR, the structure and the absorbency of the hydrocarbon before and after the treatment. It has very significant reductions and significant simpler the structures. And then yes, and then for TCLP itself, it can also for biosurfactants, they pass all of the TCLPC parameters, which is based on the regulation. It could be managed as a non-hazardous waste material and can be discharged into the landfill class 3. So that's a good view that we can use these biosurfactants. So for additional data,
sorry, the time is up. Can you?
Right. Yes, okay, this is the germination. We can also see that these biosurfactants also can increase the quality of the soil. And yeah, currently we are working on these journals. And as you heard before, it's a good use for us. We can use these biosurfactants for extractor, and it can increase the quality of the soil after the contamination process. I'm sorry for the delay. Thank you very much.
Okay, thank you very much for your presentation. So now we proceed into the Q&A session. So first, is there any questions from the participants for these three presenters? Please, if you have.
I want to ask for the last presenter, Miss Lely.
Yeah, please.
Yeah, I want to ask about the mixing method. I'm interested about the shakers, horizontal shakers, right? And the centrifugal mixing method. What's the difference and why the combination of both is better?
Yeah, can I answer it directly, Mrs. Moderator? Yeah. Yes. So the horizontal shaker having, of course, the slower motion, and it's horizontally. If you're a I don't know what's your background, but it's physically horizontal shaking, and it cannot work very in a rapid motion. So yeah, it's around 150 RPM. While the centrifugation, you can use it practically until 2000 RPM. In the beginning, in the process of separation, we normally use mostly using the centrifugation, because you can have the attachment between the liquid and extractor and the soil, and also it's directly separated. So centrifugation can do both in a very quick, and the absorbency, and also the the separation is quite high. But the horizontal shaking in the beginning can give more surface to the soil, so that the attachment between the extractor and the oil that attach into the solid material got more attachment than when it's centrifuge in the rotation mode. It is more increasing. So I hope that would answer your question. If you are in a physical engineering or a physical chemist, you are welcome to give suggestion for this, and we can comment regarding this. But yes, in perspective of process, I just see this is giving a more removal efficiency if we're conducting both. Yeah.
Okay. Yeah, thank you.
Thank you.
Okay, thank you. Is there any other question? So if there is no question, I want to ask Fatur for your presentation. So your presentation is about project management monitoring or project planning?
It should be on the monitoring, Ibu. But my study is not really focused on the digital solution to do the monitoring, but instead of, I would like to highlight the change management when an organization apply such solution.
Oh, so it's not digital monitoring, not real-time monitoring like that? No.
It can be monitoring, Bu. It can be real time. It can be real time monitoring using digital application. But if I focus on the digital application, Bu, I think it's the knowledge. I think it's just currently common knowledge. But I see that there is a gap in conducting the change management when we apply. Because first, when we apply to an organization, I think there is a gap, many gaps there, like from the process and then from the capability for its people. So I would like to touch the change management.
So for your study, are you apply your monitoring system to a project or to a company, something like that?
Yes, Bu, to project and for company. I myself is basically a consultant, Bu. A consultant. I work in the digital / energy consultant, and then my client usually a BUMN that is would like to introduce such solution. To do the solution, I work with the IT engineers, of course, and then sometimes we also work with the organization to create the change management program.
Okay. Okay, I think it's really good. Yeah, good luck for you for your future. So, is there any other questions from the audience? If not, I have one question for Gusti. So I don't really understand the effect of calcium carbonate to the degradation of methylene blue, because actually the component, the active component is the ferrite, isn't it?
Yes, the catalyst is ferro.
Yeah, ferro. Yeah. So you, in your data, you say the higher ferro concentration, then the methylene blue degradation is much better. Yeah. But what is the effect of calcium carbonate here? Because from the eggshells, you get the calcium carbonate and you add this to your system. Then what is the what is the purpose for that?
Okay, actually, ferrocatalyst has low catalytic activity because the surface area is limited. So we need to put in the support so it can larger the surface area. That's actually the function of calcium carbonate. But I realized that I need we need more characterization such as XPS to analyze how much the ferro can be loaded into calcium carbonate. Maybe that's the next project of our works.
No, I mean, did you check the effect of calcium carbonate itself? Because I was, the result is if you increase the concentration of ferrite, yeah, ferro material, but you don't increase the concentration of calcium carbonate, isn't it?
Yes, yes.
Yeah, I mean, this study is to study the effect of calcium carbonate. Why don't you increase the concentration of calcium carbonate? So we don't actually know the effect here.
Yep. Okay. Thank you for your suggestion. That's we are running the concentration of calcium carbonate right now, so I cannot show you it here.
So for a further study, yeah. Okay. Okay.
Yes,
thank you
for further study.
Yeah,
thank you so much. Thank you so much.
Yeah. Okay. So before we continue to the second session, I suggest could we take a group picture first for documentation? So probably, yeah, Adhika maybe can guide us for picture taking.
Okay, so okay, Miss. In count of 3, I'm gonna take a picture of us. Wait, I'm gonna wait for 1 minute to all the participants open their camera, maybe until 10:56. Okay, it's already 10:56. So in count of 3, I'm gonna take a picture. 1, 2, 3. Okay, thank you.
Okay, thank you, Adhika. Okay, so now we can continue to the second session. We start with the first presenter. Edwin, please, you can start your presentation.
Yeah, thank you.
Yeah.
Let's share my screen first. Okay, thank you for the opportunity. Today, I will present my thesis work about particle in cell solver using least square moving particle semi-implicit. I know that this title is too technical, but I will explain later for a general audience so everybody could understand what I'm doing here. First, particle in cell is the numerical method used for low density gases and for non-equilibrium plasma simulation. In aerospace engineering, we try to make a numerical model to model the so-called Hall thruster device. Now, Hall thruster itself is contained of plasma, and it is used for the satellite propulsion system. And this device will be simulated numerically using our proposed method of particle in cell using Ls Mps. I will explain what is particle in cell. Particle in cell is the method where the particle itself described in red here, and it is the real particle and also the background particle, which is in gray. And numerically, the real particle is moved through the domain, and the background particle is still constant and is still there. So this method is required because in plasma, usually the problem is not equilibrium and not in equilibrium state. So this method is required. Okay, I will continue to the flowchart. I hope this is quite describe what we are doing here. First, the move particles here is to move the particle from one place to the others and to simulate the particles. And then we need to weight the particles to the grid for solving the field equation, and then weight it back to move the particles. It will be clear in this slide when the particles is moving using Lorentz force. If you know from the physics, Lorentz force is force due to electric field and magnetic field for a charged particle. And then the Lorentz force itself will change the density, the number density in the simulation, and it is will affect the governing equation in the field equation, and this part will be my pointer will be solved using Ls Mps. Now this is our proposed method to solve this equation, and then the electric field obtained from this Ls Mps will be used again for the Lorentz equation to move the particles and so on. And also for the validation, we will validate all of the simulation sub function, and also validate all of the function using called plasma oscillation benchmarking. First, if you are not familiar with Ls Mps is the discrete differentiation method for randomized particle, like in this picture. What it is called is to know the spatial differentiation. So like to know dx dy, I'm sorry, d per dx, d per dy, and so on. So the use is to solve the equation. If you, from the basic physics, we know that this is the equation for electrostatic, and I use this equation when the rho is obtained from the charge distribution, and then after that we could get the electric fields to move the particles in the simulation. This is the Lorentz force for I use the relativistic equation and when move it using Weiss methods numerically. And this is the weighting method. It's quite simple, using a linear method based on the area. So when it is close, it is larger proportion. When it is far, it's smaller proportion, like this. And then this is the theoretical result for the plasma oscillation frequency, and we will use this to benchmark our result. The validation result, I use the Ls Mps solver to solve the Poisson equation. I use the analytical equation here and the analytical solution also here. And the result, I use the Ls Mps compared to the standard VVM for the structure grid. I use the same configuration, even though the Ls Mps could solve the particle in randomized configuration, but I still use the same to get the one-to-one comparison. And as expected, using the root mean square of the difference between the analytical solution and the result, Ls Mps is very accurate. You can see here in the picture, it's quite the same, but it's slightly less accurate than finite volume because of the nature of the particle distribution, not depends on the grid. So, but it is still accurate and it can be used for the work. Also, I validate the moving particles. As you know, the Lorentz force before, I divided into two, the electrical acceleration and then the magnetical acceleration. For the electric acceleration, as you can see, our model called fit well the analytical result. And I also built the classical model. It is quite good in the beginning, but for the high speed, it more than one or speed of light. So it's not realistic, but it's still good and for the low speed. And for the magnetical circular, if you know the chiromotion in physics, it's quite the same. You can see that the trajectory is circular and it is really fits well. And the last one is the plasma oscillation. As I use this for the global benchmarking. So when we are successful in solving this plasma oscillation, it means that our solvers from the Ls Mps for the weighting, from the Lorentz force for acceleration was working well. So here plasma oscillation is the oscillation due to the charge imbalance in the domain. So the electron is slightly placed from the ions, but the ions is not allowed to move. Then we just release. So the electrical displacement will create a charge density, will create a potential energy as you can see here. And then when it's released, the electron will move back and forth, and it will change from a potential energy to kinetical energy and so on. As you can see that the simulation could conserve the energy well, and it is the period of the oscillation, and it is quite the same with the solution of the theoretical 35.7 and 35.2, and it's very close. Yeah, and the last one is the conclusion of the Ls Mps method. As I know that the Ls Mps is not as accurate as VVM, but it is compatible for the PIC solver and can be proved to be able to solve the plasma oscillation. And the particle solver algorithm also could resolve well and can be used for the future works. And the future works also maybe we can try the different weighting scheme for the PIC weighting itself or the Ls Mps parameters. So the result could be more accurate, and also some collision handler also could be added to simulate the real device like the Hall thruster, which is currently on progress in aerospace engineering department. Yeah, that's all for my presentation. Thank you.
Thank you for your presentation. So we continue with the next presenter, Okri Wahyudi, please.
Okay, good morning, everybody. Thanks for the opportunity. Okay. Okay, I will to introduce my paper, which title is Material Selection and Design of Orbital Maneuver of the Solar Cell Orbit to Explore the Outer Solar System by Okli Wahyudi and my supervisor, Hakim Lutfi Malasa. Okay, this is my introduction list. 1. What is the solar cell? Solar cell is the propulsion method of the spacecraft using photon emitted by the sun. You can see the figure beside. 2. Graphite and carbon form are extremely light and strong, so that can be using to create sail. 3. This paper demonstrates the effect of the diameter and limb darkening of the sun using Monte Carlo method. 4. Solar cell was simulated by using Newton's law of the motion and gravity with the Runge-Kutta-Werner integration method. 5. The simulation optimized the orbital maneuvering of the solar cell to maximize the change of the momentum. Those are my paper method. First, solar cell forced by photon. Solar cell change momentum from the photons depending on the solar cell distance from the sun, reflectivity, emissivity, and the ratio of the mass per area of the cell. Thus equation vigor beside explain those force. Total force depend on absorption force, reflectivity force, and transmission force. Next, the sun limb darkening can be modeled in the following equation below. Next, second, cell material selection. This paper using two layer cell, emission and reflection layers. The emission layer is made of graphite nanosheet, and the reflection layer is made of the several metal option, aluminum, beryllium, chromium, and so on. The combination of graphite metal with the high force will be chosen as the reflection layer material for the solar cell. This paper have some result. First, graphite molybdenum cell. The cell with graphite molybdenum can produce the highest acceleration, which is important by solar cell to get to the outer solar system, such as Kuiper belt and Oort cloud. Second, theta and P relation. Theta is angle between R and cell vector, and P is angle between R and velocity. The inward trajectory graph, right figure, is the opposite of the outward trajectory, left figure, with the relation in equation below. Next, third is my simulation. Solar cell with 0.01 kilogram per meter square solar cell with 10,000 meters square area can carry 92.6 kilogram payload. Solar cell have using two main maneuver: inward trajectory, which mean increased momentum, and outward trajectory, which mean decreased momentum of the solar cell. This solar cell use three steps of the maneuvering. One, inward trajectory maneuver, or ITM. You can see in figure top left figure. Solar cell is assumed to be 1 AU from the sun in the circular orbit. 1 AU is mean distant Earth from the sun. Next, solar cell perform ITM until produce an inward spiral orbit and the final perihelion nearly 0.0144 AU. Next, semi-outward trajectory maneuver, or SOTM. SOTM is combination of the two maneuvers, namely the outward trajectory and the 90 degrees maneuver. 90 degrees depend on the theta of the solar cell. This maneuver aims to increase orbital energy by enlarging the end of aphelion point. You can see the top right figure. And the next step is escape trajectory maneuver, or ATM. ATM is also a combination of two maneuvers, namely outward trajectory and maneuver 90 degrees. The outward trajectory maneuver is used when the solar cell approach and slingshot near the sun until it's left the solar system. You can see at the bottom left figure. And the bottom right figure is combination of all of the maneuver. Next, the 0.001 kilogram per meter square solar cell with a 10,000 meters square area can carry only 2.6 kilogram payload. This has two types of maneuvering. One, direct maneuvering or DM. Solar cell is assumed to be 1 AU from the sun, and then solar cell perform at an outward trajectory maneuver until escape orbit of the sun. You can see at the top figure. And the second is sun flyby maneuver or SFM. SFM is combination of ITM and ATM, but without using SOTM. Solar cell is assumed to be 1 AU from the sun, and then solar cell perform ITM until solar cell produce its final perihelion orbit 0.012 AU. You can see the figure bottom figure. Solar cell perform an ATM by maneuvering an outward trajectory to slingshot near the sun about 0.015 AU until it's left the solar system with the high speed. Okay, this is my conclusion. First, the combination of the graphite molybdenum is very well applied as a cell material of the solar cell with maneuvers near the sun with outer solar system target. Second, solar cell which are very small from 1 AU, the effect of angular diameter and limb darkening of the sun need to be taken into calculate. Third, the 0.01 kilogram per meter square solar cell has a final speed up to 134 kilometers per second or about 4 years to Kuiper belt object. The 0.001 kilogram per meter square solar cell has a final speed up to 440 kilometers per second or about 7 years to solar gravitational lengths. Okay, this is my reference paper and thank you very much.
Okay, thank you for your presentation. So now we continue with the next presenter, Muhammad Iko Safriuda Maulana.
Yes.
Yes.
Can you hear my voice clear? Can I present my own PPT because there is slight change in the PPT that I sent?
Yes, you can.
Okay, thank you. Okay. Excuse me. My name is Muhammad Iko Safriuda. Here I will present our research with the title of the effect of different microphysics scheme for health simulation on VRF health case model, case study in Central Lombok 24 February in 2019. Next. And this is our outline. First, in cloud physics, the process of health starts from clouds that are formed through the process of supersaturation of air against liquid water. This supersaturation process occurs in the atmosphere to lifting air through convection, convergence, orographic or fronts, which causes the air to expand, and adiabatic cooling occurs. When it occurs, some drops of water turn into supercooling water, and some drops do not change depending on the condensation nuclei, and this process is called the supersaturation process. And normally, drops of pure water will not undergo homogeneous cooling at -40 degrees Celsius, but when the condensation nuclei is present, cooling process can occur at temperatures a few degrees below 0 degrees Celsius. Supercooling water that turn into ice crystal can grow to a size larger than water drops. So the ice crystal will fall and collide with other drops. When the ice crystal collide each other, snowflakes are formed, but if the water drops are concentrated in the cloud, it will form hailstone. This hailstone will fall at the freezing level and melt. It emerges from the bottom of the clouds as raindrops. When the ambient temperature on the surface is relatively cold, the falling hailstone cannot melt until it reaches the ground, so hail occurs. In the tropics, hail is rare due to the extreme cold of the surface environment. but the convection associated with strong updraft and downdraft is absent. The effect of updraft and downdraft in storm clouds can drop hailstone into clouds very quickly to the surface that hail in the tropics is possible happened. And what is Werf-Helmholtz model? Werf-Helmholtz model is a combination of a time-dependent hail growth model and a one-dimensional steady-state cloud model that has been integrated into RW modeling system to predict the hailstone size on the surface. One of the assumptions used in the Helmholtz model is the use of cloud modeling to simulate an updraft within a storm cloud combined with a time-dependent hail growth model to allow hail embryos to move in 3 dimensions through the storm cloud system. Hail embryos are fed into the updraft and tracked as they are raised by the updraft to the cloud top growth and rejection of hail particles in the lower layer. And the utilization of 4 different microphysics schemes we use based on previous research. There is Morrison 2, WSN6, Thomson, Graupel, and Goddard GCE. And the data, we used initial model from NCIP GDAS data final model with the resolution of 0.24 to 0.25 degree and 6 hours of temporal resolution. And length of the data used at 0, 6, and 12 UTC, which is the first 6 hours for spin-up time. And synoptic observation data obtained from Lombok Barat Climatological Station, and weather radar data every 10 minutes obtained from Zainuddin Abdul Meteorological Station. And this is a domain configuration of our research. To verify our model, we used compare the output of the models with the observation radar data using 4 methods. There is RMSE, correlation coefficient, mean bias error, and eyeball verification. And the results of verification model output is, in general, of the 4 microphysics scheme studied in the study, the best use for estimating surface variable is the WSM6 microphysics scheme. This is because the correlation and MBE values show a moderate category and are close to 0 even to the underestimation of the surface observation data and maximum reflectivity data from weather radar observation. And the estimation of time occurrence marks hailstone size and particle structure of cloud. The results of the maximum hailstone size estimation in each of the microphysics schemes studied is in metal case. The hail peak and hailstone size estimation of the first scheme showed different results. And if you viewed from the cross-sectional vertical cloud profile, the WSM6 scheme showed the best scheme to represent the vertical cloud structure and the location of the hail occurrence according to the radar observation, but the timing of the incident doesn't match with observation data. Meanwhile, other scheme represent different patterns and reflectivity value from VCAT radar product images to Morrison 2, Thomson, Graupel, and Goddard GCE scheme show the maximum reflectivity value of more than 52 dBz, but the vertical cloud structure pattern is different from the radar image pattern. And estimation of hail time occurrence makes hailstone size and vertical structure cloud. Assuming that freezing level at the altitude using the average criteria used in tropics is that a layer of 5 km of about 560 km, there is a 560 millibar, there is a potential more than 80% of hail in the Bante village, which occurs at each UTC. So the Thomson-Graupel scheme is the best scheme for simulating the timing of the hail events. And when we viewed from the maximum hailstone size in the Morrison 2 scheme of 60 mm, WSM6 18 mm, the Thomson-Graupel scheme in 90 mm, and then the Goddard GCE scheme of about 80 mm. This estimated hailstone cannot be verified with observational data due to the unavailability of hailstone diameter measurement at the same time of the incident. So next, we research of microphysics scheme hail producing cloud, And the results show that all microphysics schemes show the presence of water vapor in 950 millibar layer to the 250 millibar layer with a maximum value of 16.1 until 18.2 in the height of 950 millibar. The presence of water vapor particles at a height above the freezing level layer because of process of changing the shape of water vapor into ice of or ice pores directly without passing through the liquid phase. Hydrometeor cloud water particles show the mixing ratio in the Thomson scheme has the highest value among other schemes, which is 0.92 gram per kilogram, and the Goddard GCE scheme show the second highest value of 0.88 gram per kilogram. In general, all schemes show the presence of cloud water particles in the layer altitude below the above of freezing level, and this indicates that phase change of the hydrometeor particles into supercooled water. Furthermore, there are ice particle in the 300 millibar to 200 millibar layer with a maximum value of ice particle mixture of 0.12 gram per kilogram in the WSM6 scheme and 0.1 gram per kilogram in the Goddard GCE scheme. While the Thomson gravel and the Morrison 2 scheme do not produce ice particle at all high altitude layers. And the presence of ice particles in this relatively high layer indicates that ice particles a little contribute to the formation and development of ice in hell processing cloud. And the process of formation and of gravel in clouds occurs from very cold cloud drops or supercooled water when they are lifted upwards by an updraft, and gravel mixing ratio values are seen in the 600 millibar to 150 millibar layers, with the maximum ratio values are seen in the 100 millibar to 150 millibar layers. And the value of WSM6 scheme is 2.21 gram per kilogram and Goddard GCE scheme is 1.11 gram per kilogram. While in other scheme there is no gravel, and rainwater particles were observed in the XT 100 millibar to 400 millibar layers. The maximum value of rainwater particles is from 0.72 until 1.76 gram per kilogram from all schemes. The pattern of the rainwater mixing ratio graphs show almost the same patterns from all schemes. The Goddard GCE schemes show the minimum rainwater mixing ratio at 550 millibar layer and WSM6 scheme at the 400 millibar layer. The Thomson gravel at the 450 millibar layer and Morrison 2 at the 400 millibar layer. And this is our conclusion. First, in general, the weather surface parameter verification shows that Warp-Hall gas output can be used to estimate surface weather parameters and maximum reflectivity properly, but the best scheme used to estimate weather surface parameter is the WSM6 microphysics scheme. The spatial, temporal, and vertical distribution patterns of all schemes can show the presence of hell-producing reflective clouds with different patterns of cloud vertical structure, location hell time occurrence, estimation maximum diameter, hailstone size, and values of vertical maximum reflectivity. However, all schemes can show a maximum reflectivity value of more than 52 dBz according to the Permata threshold. When viewed from the time of hell events, the Thomson gravel scheme produces the time of hell occurrence matches with the observation radar. The Morrison 2 and WSM6 scheme are best used to estimate the location of the hell occurrence and the diameter maximum of hailstone size in terms of 1.6 until 9 centimeter. And the mixing ratio of water vapor, water, and supercooled water can be modeled very properly, and however, only the WSM6 and Goddard GCE schemes can display ice and gravel particles in the cloud. Only can display ice and gravel in the cloud. So the WSM6 and Goddard GCE scheme are the best microphysics scheme for estimating the microphysics process of hell producing clouds using reference in this case. And this is our references.
Okay, maybe it's enough. The time is up.
Thank you.
Yeah, thank you for your presentation. Yeah, thank you. So we continue to the next presenter, Adi Prasetyo. Please, you can start.
Okay, check. Does my voice sound clear?
Okay.
Okay. Permission to share screen. Is my presentation appeared on the screen?
Yes.
Okay. Okay. Good morning, good afternoon, ladies and gentlemen. Thank you for the time for me to present the part of our study entitled "The Application of Rosmo Equation for Mineral Exploration in Epithermal High Sulfidation Gold and Silver Deposit of Miwa Aceh, Indonesia." My name is Adi Prastyo as a presenter on behalf of our authors. These are our outlines. The first introduction, then Maturation Method, discussion, and the last part is conclusion. The first introduction. So exploration is an important step of mining field. One of method of exploration is geochemical exploration to avoid errors of location for more detailed exploration. But sometimes geochemical exploration fail to determine the primary source or anomalies due to several factors. To overcome these problems, can be tried to adopt the Rosmo equation, which is used in criminology to estimate the place of residence of criminal with some data on the location of crime scene. This is the Rosmo equation. Anomalies of geochemical data are considered as a crime scene, and the primary source is considered as a criminal residence. The purpose of this research are to modify the Rosmo equation so that it can be used in mineral exploration and to determine the modified Rosmo equation variables. Okay, next. Second part is Maturation Method. There's two data that we use. The first is geochemical samples of grab and channel sampling taken from some location of Miwa Gold project. Example, then analyze using fire atomic absorption assay for gold and ICP AES for another element. And the second is the primary source is the location of the primary source. Primary source is determined by interpretation of mineralized zone that is exposed to the surface. This is the picture that I mean. So the primary source is determined the interpretation of mineralized zone in the red line, and that is exposed to the surface at the borehole 22, the location of the borehole 22. Data processing, the Rosmo equation can be modified into this, where the difference is the power constant of the second term of the equation, where the previous is G min F, but in this is G, this G. And the element which analyzed are copper and lead for mobile elements, and gold, silver, and zinc for immobile elements. And then the next is we determine the upper threshold for anomaly using this equation, where the threshold is the average of the mean plus 2 multiplied by the standard equation. The next step is to determine the buffer zone by use the upper threshold distance from the location of the data of primary source for immobile elements and lower distance for mobile elements by this equation. Then the next part, if the total amount of the data inside and the outside of the buffer zone, after we determine the buffer zone, radius buffer zone, on the element is less than 100, then the normalization is carried out to determine the maximum percentage limit for the data. It's inside and the outside of the buffer zone. Using this equation, the variable of F is determined by the first term of the equation, and the G is by the second term of the equation, which the amount of the percentage is less than or equal to percent maximum data. The last part is to determine the K constant. Use this formula. Third part, result and discussion. So Rosmo equation is slightly modified because initial assumption is different from the criminology field, from a serial killer or other criminal, which then commits several crimes near his residence. In this case, described as a inner area of buffer zone, and the constant G will always be smaller than F. But it is different from the immobile mineral characteristic. Then after we determine the upper threshold, these are the upper threshold of each element that we analyze. This element, gold, silver, and so on. This is the threshold by using ppm, part per million. Now, this is the example distance of distance graph of element can be shown in below, where for immobile element is for gold and copper is for mobile element. From the 5 of the graph, buffer zone is determined about 300 meters. The amount of the data is on the table below. This is the element, this is the inner and the outer of the data. This is the percentage of the inner of the data. From each element, we can see that all of the element is less than 100. So we must to use the equation of percent maximum data. So this is the maximum percentage, and after we calculate the maximum percentage, this is the maximum percentage of each element in the inner and outer buffer zone. So we can calculate F and G constants of each element. So the next is the constant of K and the probability of each element as shown below. And this is the probability. It can be shown that all of the element almost 100%. The conclusions, the modified Rosmo equation can be applied in the field of mineral exploration. And the second, the value of buffer zone radius is 300 meters. And the constant F, G, and K respectively for each element are 0.18, 0.31, and 8.65 for gold, 0.001, 0.014, and 1.13 for silver, 0.05, 0.04, and 1.69 for copper, 0.09 both for F and G constant, and 2.69 for lead, 0.19, 0.26, and 12.76 for zinc. These are the references that we use. Thank you.
Okay, thank you for your presentation. So now we continue with Q&A session. Is there any questions from the audience, please? Pak David, maybe? Is there any question? Okay, so maybe I will ask a question. So for the last presenter, could you tell me how to get the data of the elemental composition? This is for the elemental composition in the land, isn't it? Inside of the Earth?
Yes.
How to get this kind of data?
So the data is that we use is secondary data from 2013 from geochemical examples, from grape sampling. So if we found the rock, so we grab and we describe it, and we analyze with this ferrocell for gold and ICP AES for another element. So and channel sampling. So if we make the channel. So the channel is analyzed too by using the same analysis. Yeah, like that. Hello, ma'am.
But anyway, you take the data from the earth, from inside the earth, or from like only from the rock on top of the soil?
Only the top of the soil.
Oh, so this data is only on the top of the soil. We don't know what is inside the soil, isn't it?
Yes, and the second, this is the secondary data. So,
okay. So your work, this study is to find out the most probable point, yeah, to establish the exploration field.
This research to apply the Rosmo equation for from criminology field to mineral exploration. So this is like the reverse engineering. Before we, so the output is we can make the database that classify based on the same geomorphological or one kind or the kind of deposit or geological event. Then we can use the variable to estimate the probability of the area to next exploration, maybe to another place that the same geochemical, geomorphology, and so on.
I see. Okay, I see. So maybe this is important for the exploration, yeah. Which area we want to make the mine, yeah, and so on. Okay, thank you for your explanation. So I will ask for another question. So for the first presenter, Edwin, so you make a simulation, yeah?
Yeah.
To estimate the particle movement or
right.
In plasma.
Right.
This is applicable for every kind of plasma. I mean, oxygen or argon. This is
yes, it's applicable for all of the plasma, and just it depends on the property at the end. So like the mass or the radius for collisions, for the cross section, and that. So in general, it's a general solver. Yeah.
I see. So what is the example of application? Why we need to calculate this particle movement in plasma?
Right now in aerospace engineering, we try to model the, like I said before, the Hall thruster. Hall thruster is the satellite propulsion system, and it contains of plasma. So the energetic ions, the charged particle will be accelerated in the domain, so it can create a thrust to propel the satellite and control the movement. So we in aerospace engineering is trying to model that, and the first step is to make the physical model of the standard, the basic concept first. Then after that, the application of the Hall thruster.
I see. Okay, thank you. Very interesting. Thank you. So I would like to ask another presenter. So maybe the second presenter, Oakley Wahyudi. So are you still here? Is still here? No, maybe he. Oh yeah.
Oh,
yes.
Yes.
Okay. Okay. So you study about material selection for solar cell orbit. So for like the device is sent to the solar system, like to outer space, like that, right? So what is the most important thing to consider if you want to select the material for to be used in outside the atmosphere? Yeah?
Yes.
So what is the most important consideration? Is that the temperature? It should be able to withstand high temperature, or is it another, the pressure? How about the pressure? The pressure must be lower, yeah, near vacuum.
Yes.
Something like that. So what is the most important consideration here?
Okay, I try to answer that question, Miss. Before I can see, because the solar cell changes momentum from the photon, depending on the solar cell distance from the sun, reflectivity, emissivity, and ratio of the mass of the per area of the solar cell. So the importance of this cell is the choose the material is very strong, reflectivity and high melting point, because the solar cell targeting for the Kuiper belt object. So that's need high energy. So the solar cell need high energy. So solar cell distance from the sun is we create a solar cell very close near the sun. So the cell need strong and reflectivity material. So yeah.
This is interesting you say about reflectivity. How about the electromagnetic wavelength range that needs to be considered? You know that, for example, if we have UV radiation that reach the Earth, like it cut by the atmosphere, but if you are out there, then you get the full range of the spectrum. So we need to understand about this as well, isn't it?
Yeah. The metal material using from this cell, we can calculate the reflectivity of the material using using a reflectivity equation depending on all of the wavelength spectrum of the sun. So yes, yeah, reflectivity depend on wavelength spectrum, but I have one equation that's calculate reflectivity of the metal in all of the wavelength. So yeah.
Okay. Okay, yeah, interesting, yeah. It's actually for material science, the application is so wide, yeah. For so if we see in this session also, we have a lot of application. Okay, thank you for your explanation. So for the third presenter, Muhammad Iko.
Yes,
excuse me, I don't really understand, yeah, for this. So this is for the to estimate the weather, or what is the main purpose of this study?
The main purpose of this study is to look the effect of different microphysics game in modeling weather system using weather research forecasting modeling system or
for weather forecast, isn't it?
Yes, it could be applied as weather forecast or analysis forecast.
Oh, okay. So you studied about what water or concentration in the atmosphere in cloud, isn't it? Water, vapor, and ice. Is there any difference regarding? So
okay, in cloud physics, it called microphysics. Microphysics hydrometeor particles in cloud microphysics, and the difference of each type of hydrometeor is for in the and the content of each hydrometeor particle itself.
Also, so the composition of these elements will determine the weather, or what?
Oh yeah, it could be effect of formation of the clouds. So in cloud physics, there is some cases of hydrometeor, and each type we could predict the volume of each type, and which is it couldn't be observed with any other tools such as satellites maybe or sounding, but I think it could be observed with sounding that or radio sound maybe. Yeah.
I see. Okay, so sorry, because this field is very new, yeah, for me. I've never studied about this before, so it's very new. So anyway, if you measure this, you need to measure in a specific height. I mean, in atmosphere, you have many layers, right? You have different kind of clouds out there. So you need to measure in a specific height from the Earth, or what? Is there any, the height, where is the position of the cloud? how the height is a parameter to consider or not in this kind of study, or it's not?
The height of each hydrometeor particle, did you mean?
No, I mean the height when you study the cloud, yeah. This is how many kilometers from the surface of the Earth? Is it a parameter to consider in your study or not? This height? No? I mean, because if you go higher, the composition of water, vapor, and ice must be different, right? So is there, is it one of the consideration in this study or not? I just wondered.
Maybe I just answer. Consider the.
Okay, never mind. I just wondered just now, so it doesn't matter. Okay, so now the time is already 11:50 and we hear the azan now, so it's better to stop our session. Is there any other comments or from participants? Please, if you have anything to say. No? So if there is no other question or comments, maybe we can finish the session. How about this, Adisa? It's okay?
Okay, it's okay.
Okay, so now thank you, ladies and gentlemen, all the participants for your participation in this conference. I hope this event can give us a lot of new insight and can be an event for collaboration as well, because we know now studies from different departments, from different program, and there is a lot of interesting studies that we heard in this session also. So I hope we can gain a lot from this session. Thank you very much for your participation, and see you later in other events. Thank you. See you, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much.
Thank you.
Thank you.